All right, so we had review day yesterday, went over a bunch of problems that were focused on section 2.1, which we've been covering this week. Hopefully you did have time for hot chocolate, although it sounds like maybe Sunday would be a better day to enjoy a hot chocolate with the nice cold air and snow moving in. I think that we really were just focused on these first 26 problems, which were associated with section 2.1. Don't worry, I know these other ones look like a lot of fun, and we will get to play with those next week. There were not very many questions. There were, nobody really showed up to the help session yesterday, and on top of that, I think I only had a couple questions submitted, so I won't go over very much. If you are behind and you're just finishing the review Friday morning before the quiz, don't forget that in the back, starting on page 335 for this review, you have all the answers worked out for both the graph interpretation questions, all of the algebra questions, which was the majority of the questions last night, were these algebraic evaluation problems, and then a couple more graph interpretation problems at the end. The graph interpretation problems, I would just, a small bit of advice, make sure you know very, very well what you are approaching. What x value am I approaching, and what side am I approaching it from, right? So like right here, this is not just telling me I'm approaching to, this is telling me it's a one-sided limit, and I only really care about approaching to from the left. That's a left limit. So that would be, x's are coming into 2 from this side. And if there is no little, so here's one with a little plus, so that would be a right limit. So I'm only coming into 1 from um, the right side. And so this one would be 1. This one would also be 1. Now, if it's a two-sided limit, it won't have the little plus or minus. It'll just ask you if the limit exists at that point. Does the limit exist at 2? And that's when we really have to understand what limits are asking, and are we approaching the same height as we move. If x's move towards 2, are we converging to the same height? That's really what's important. And then don't forget, there might be just some regular kind of algebra questions. Interpret the function's value at 2. And of course, in that case, it looks like that answer up here would be 2. Yeah, no questions at all on this this set of problems where you were evaluating limits algebraically. You can certainly confirm them graphically at home, since it's kind of an open note, open calculator quiz. But sometimes you can just use substitution and put your number in and simplify it. But sometimes you can't, and that's where the problems get tricky, and that's where you need to know your algebra tricks like factoring and such to manipulate the expression until we can substitute, and then also the trig identities. Um, Really just one primary trig identity, right? The sine of kx over kx, yes, x approaches 0 will always be equal to 1. And there, like I said, there were a couple more of these graph interpretation problems at the end. This one was given to you, and this one we had to graph ourselves. Let's go ahead and take a look at number 25 here. So it looks like the breakpoint is -1. So we've got scale of, you don't have to necessarily use this on this problem, but definitely pay attention to scale on any graphs that are given to you on the test. It doesn't always go by ones. This one says, let's go from -4 over here to 4 over here. So it looks like the x scale is actually going by 1/2. So this would be 1, 2, 3, 4, -1, -2, -3, -4. So -4 to 4, and then 16 on the Y scale. So that means we'd be going by 2s every jump. 2, 4, 6, 8, 10, 12, 16, and so on. Okay, -2, -4, -6, -8, -10, -12. So pay attention to scales so that we get proper uh, analysis. But what we're really looking for is this breakpoint right here at -1. Actually, at -1, it looks like we have a value of 3. So -1, 3. So 3 would be between 2 and 4. So we'll go right there. Okay. That's the actual function's value at -1. To the left of -1, so when we're less than -1, this is the function that controls us. So let's figure out where we start. At -1, if I plug a -1 in here, -1 squared is 1 times 2 is 2 plus 5 is 7. So here's 8, so less than 8 is 7, and I'm going to get an open circle there, right? And then this is just a positive parabola, x squared graph. It's really going up. So all I really need to know is it's continuous, but if you wanted to throw another number in there just to get more accuracy, you'd be welcome to. Negative 2 squared is 4, times 2 is 8, plus 5 is 13. So if you wanted to get another number in there, go for it. But mostly these limits are going to be interested in what's happening at the breakpoint. So here's an idea of what the left half of the graph looks like. On the other side, we've got the right half, which is also a positive parabola. Looks like it's going to be increasing a little more quickly with an a value of 3. But let's plug -1 in and see what the breakpoint is. -1 squared again is 1 times 3 is 3 plus 2 is 5. So -1, there's 4, so 5 is going to be right here. And then 0 is an easy number to plug in, right? You just get a 2, so it looks like this guy's coming down before it goes back up. In fact, it looks like this would be the vertex at 2. And then it would start going back up. You plug a 1 in and you get back to 5. And then like if you plug the 2 in, you get, what, 14, I think? So that would be right about here. All right. Now we got a nice little sketch of our graph. I didn't mean to make this part so straight. So now let's go ahead and get into the interpretation of what they're asking about. What is happening? And once again, the breakpoint was, was -1. And check this out. What's happening as we approach -1 from the left? What happens as we approach -1 from the right? What is the limit as we approach -1? What is the value? What is the value of the function at -1? So most of the questions definitely revolve around -1. It looks like as we approach -1 from the left, so I'm coming in this direction towards -1, our function is dropping down towards this point that we graphed, and we found that was at 7, didn't we? So that's going to be 7. The height is 7. On the other hand, as I approach -1 from the right, so this time we're coming into -1 from this direction, the positive x's, okay? Our values are moving a little bit up towards this value. Remember we said that value right there was 5, and you could easily get those by just plugging -1 into the appropriate function. So as long as you know what direction it's coming from, you know which function should be used. And then as far as the overall limit, the big question is, do these limits agree? Is 7 equal to -5? Are our two sides of the graph coming together to the same location? or are they approaching different locations? And in this case, 5 and 7 are different locations, different heights. And that means that the limit of the function at -1, you could certainly call it the two-sided limit, but the limit does not exist. So we would just write d and e. You could also write no limit. I think it's quicker to write d and e for does not exist. Don't write 0, don't write, none. That's not descriptive enough. You definitely have to use one of those two forms. Now, as far as what the function's value is at 1, the graph actually told us that. The graph said at -1, the function's value is 3. Okay. The last two, we're just jumping around at some different locations. This one wanted to know, what is our function doing as we approach 2? What's happening as we get closer and closer to 2? And if I plug 2 into it, I'd have to plug it into this part of the function right here. Here, let me clean this up just a little bit. So if I plug our value of interest into this part of the function, because we're looking at 2, and 2 is definitely bigger, right? 2 is greater than -1. Remember what we got? We got 2 squared is 4 times 3 is 12 plus 2 is 14. Because the function happens to be continuous, in this area over here, what that means is you can just get the answer through substitution. You don't have to do anything that fancy. This last problem, what is the function's value at -3? That is going to be back on this side of the function. Here's -3, so it's going to be up here somewhere. And it looks like it may be off of our graph. I don't think we could get that off of our graph. Our graph only goes up to 16, so this might be bigger than 16. So let's just, plug -3 in, and we'll see what we get, right? 2 times -3 squared plus 5. -3 squared is just 9, right? So 2 times 9 plus 5 is 18 plus 5, so 23. So our answer on that should be 23. And so that's how you do those. You did have to generate your own graph, so it was a little bit more work. But you guys know how to make tables and plot points, and I know that you'll be fine with that. I did not necessarily mean to lose that. Sorry about that. There we go. So here's that graph that would be computer generated, very similar to the one we came up with. Now the last one, the graph was already there for us, so that was nice. It looks like it's kind of a weird piecewise. It looks like on the left side of the y-axis, we've got like a logarithmic graph that's been reflected through the x-axis, and on the right side, it looks more like maybe an exponential that stops at, they make us stop at 0, because otherwise it would keep going forever toward negative infinity. But it also might be like the right half of a rational function. It's kind of hard to tell, but it definitely appears that both graphs are not going to make it through the y-axis. So maybe there's an infinite discontinuity there, but it doesn't look like either one is coming in. But they don't care about 0, so we don't have to worry about that. What they really care about, it looks like, is just what's happening at -2, or I'm sorry, +2. What's happening at +2? What's happening as we move towards 2 from the left, and then what's happening as we move towards 2 from the right. That little plus means we're coming from the positive numbers from the right. And then what, does the limit exist as we move towards 2? And your answer for this will be based on these two. These two will dictate whether or not we have an answer for part C. And then what's the function's value at 2? So this one's actually going to be a little bit quicker, because we can just look up here and say, all right, the function as we approach. So there's 2 right here. And I guess we can even blow this up just for a closer look. Okay, oh, that didn't do anything. Let's try it one more time. Oh, all right. Well, I'll assume this is big enough for you to read since my pen doesn't work. But as we come into 2 from the left, the height my function is approaching looks like it's 1. So this would be 1. As I come in from 2 from the right, look at that. I'm still coming up toward that same height, 1. Okay, and that's the magic right here, is when your left limit agrees with your right limit, then your two-sided limit exists. So if these 2 guys agree, you have a two-sided limit, even if the point's not there. Even if the point's not there. Remember, limits don't care what's there, they care what they're approaching. It looks like the function's value at 2 is actually defined as 3. So this doesn't have to equal this for the limit to exist. These 2 things just have to equal that for the limit to exist. And that is the big concept of limits. In fact, if I could give you a quick 3-prong review on the most important aspects of limits before you take your quiz today, here they come. Ready? What is a limit? It's just a height that our function is trying to get to. That's all. It's just a height, which is a y value, right? A limit is just a y value. So never get confused about what a limit is. It's really just a height on your graph somewhere. And the question is, what height is your function trying to get to as you approach a specific x value? Okay. Secondly, when does a limit exist? And this is what we were just talking about on number 26. 26 was a good problem to illustrate this. Okay. First of all, you have to have a right limit that exists. So here the limit coming from the positive side, the right, exists, right? It looks like it's L. It has to be a real number. Secondly, you have to have a left limit that exists. Okay. So look, we're coming from the negatives here, right? The negative side, the left side, and it looks like it exists. But most importantly, okay, not only do those 2 things need to exist, they have to be equal to each other. Limits only exist if the 2 sides of the graph are moving to meet each other at the same height. Okay, and that's when limits exist. And finally, the third big reminder is, what do limits care about? Well, limits care about what they are approaching. Okay, what are we getting near? What are we trying to get to? Okay, does it matter if a point's actually at that height that it's trying to get to? Nope. It's not actually too worried about what's actually at that point. It's really only worried about what height am I trying to achieve. And those are the big things behind limits, which are completely different than anything that you've really seen in your mathematical past. Algebra doesn't really get too worried about that, but limits do, which is what's going to lead us into calculus. So hopefully you have a good time on the quiz today. It's a little different. It's going to be 8 problems that'll either be multiple choice or multiple select or maybe even short answer on a Google quiz. So you'll jump in there and do that, and then it'll tell you at the bottom of the quiz, like, hey, the last 4 problems are on a PDF that you're going to have to do some written work and then scan it in for me. So under the same heading where you'll find your Google quiz, the Google quiz link, I'll have a PDF that you can download, just a single page, 4 nice boxes for you to do your work in on some limit problems similar to the types that we did in our examples and that you've been practicing, and heck, I might have even thrown a bonus in for you because I know you love your bonuses. So that's it. Have a good Friday. Have a great weekend. No work over the weekend, right? And I'm telling you, this Sunday, you really may want that nice cup of Coca-Cola. Look at that. That's ridiculous. Ugh, you could like eat the cup when you're done. I'll let you end on that image. And good luck. Hope you're doing all right.